Alright, in this method, we still have to first of all consider what the denominator can't be, remembering that a denominator cannot be equal to 0, and so therefore x cannot be equal to 1. Now, with this method, what we're going to do is multiply both sides by the square of the denominator. Because remember, when you square something, whether it's positive or negative, the square of that will always be positive. So what that means is, when we multiply both sides by that square, we know that we don't have to reverse the inequality sign, because what we're multiplying by is a positive expression. Okay, so let's have a look at how we do this. So we've got our inequality here, 3 over x minus 1 is less than 2. So the square of the denominator means that I'm going to multiply both sides by x minus 1 all squared. Alright, now when I do that, on the left hand side, because I've got two of these essentially, I've got x minus 1 and x minus 1, one of them cancels out with the denominator. So I'm left with 3 multiplied by x minus 1, which is 3x minus 1. Oh, sorry, not minus 1, minus 3. And on the right hand side, I need to expand my x minus 1 all squared. So I'm going to leave that 2 there for now. X minus 1 all squared becomes x squared minus 2x plus 1. Next, I'm going to leave the left hand side, so 3x minus 3, and I'm going to expand this bracket, so 2x squared minus 4x plus 2. Now I'm going to get everything onto one side. I'm going to make x squared positive, so I'm going to make the left hand side 0. That means I've got 2x squared. I'm subtracting 3x, so I've now got negative 7x, and I'm adding 3, so I've now got plus 5. Now I need to factorize this quadratic. So remembering that I'm trying to find two numbers that multiply to give positive 10, because of the 2 times the 5. So multiply to give positive 10, and add to give negative 7. So my two numbers will be negative 5 and negative 2. Now you may factorize this differently, but for me, I get 2x squared. Splitting the middle term, I get minus 2x minus 5x plus 5. Then factorize by pairs, so 2x is my common factor, and I'm left with x minus 1. Negative 5 is my common factor, I'm left with x minus 1. Now I have a common bracket of x minus 1, and I'm left with 2x minus 5. Now, I've turned this into a quadratic inequality. So remember, to solve quadratic inequalities, you must sketch. So coming up here, I'm now going to do a quick sketch so that I can tell where my parabola lies and what part of the graph I'm looking for. So my x-intercepts will be 1 and 2.5. So my parabola might look something like this. That's at 1, that's at 2.5. And I'm looking for the part that, if I look at this inequality here, I'm looking where the parabola is greater than 0. So reading that backwards, where this parabola is greater than 0. So on my diagram here, if I look carefully, I'm looking at the parts above the x-axis, those two parts there. And that means I'm looking where x is less than 1 and where x is greater than 2.5. Now, before I say that that's my final solution, I need to just double check what I wrote up here and check that that value 1 is not in my solution set. So 1 is not less than 1, and because it is 1, and 1 is not greater than 2.5. So that's my final solution. And that's it.